All right, so what this means, guys, we've worked with and, right? What do we do when they're asking you for and? What mathematical operation do we do for that? We times, right? For and, we multiply. And for or, we plus. Okay, so now instead of using the words and or, they can use the word intersection for and. And guys, if we're thinking of a Venn diagram, does that make sense? Where the two circles intersect, where they overlap, that section there in the middle, that is the and section, right? And then for union, that is or, that's basically everything in the two circles all added together, right? Union is all. Now, what we also need to know is we need to know the symbols for these two. So we are going to work with, if we write here and, another symbol for and is a symbol that looks like an N, a lowercase n, but it's kind of like, yeah, I don't know. It's kind of like an arch kind of thing, right? So like a doorway, I suppose, that you would walk through. The way that I remember that this is and is because it looks like an N. So and has an N in it, and the symbol looks like an N. Okay, like a lowercase n. It just doesn't have that little line in the front. And then for or, the symbol that you can use is a very similar symbol. It is just upside down. So or is like a U, like union. Okay, so do you see how the three are kind of linked together? So and is intersection. The symbol looks like an N. Or is union, and the symbol looks like a U. Okay, hopefully you will be able to remember those two. So now let's write the probability identity out. Probability identity now using these new symbols. Okay, so we remember that the probability identity starts with the probability of A or B. But now I don't want us to use the word or. We're now going to say A union B. Right, so we are replacing the word or with the actual symbol for or, the symbol for union. That is equal to the probability of A plus the probability of B. And then remember, if those two events overlap, if the two circles in the Venn diagram, if they intersect, we are going to minus the probability of the intersection of those two events. The overlapping part of those two circles, the and. Okay, so it's basically just a case of getting used to those two symbols instead of and or or. Now, guys, when you are writing a question out, right, if they've asked you the probability of A or B in words, whatever, you don't have to use the symbol. The only time where you would have to know what the symbol means is if the symbol appears in the question. Okay, so if they're asking you in a question, calculate the probability of A, and then they have that U-shaped symbol, B. Then you need to know what that means. Okay, but if you are writing your questions out or you're working out, you can absolutely use the word or and the word and. Okay, that's 100% correct. I just need you to be able to identify, recognize those symbols and what they mean. Okay. We also need to do a little bit more of, kind of terminology work. So if you can write a new heading, complementary events. Okay, I'm just going to write down what that actually means. What does it mean when two events are complementary? Okay, so two events are complementary if the first thing the events are mutually exclusive, and I'm writing and in capital letters because it's very important. Second thing, the events are exhaustive. Now, we have spoken about these two terms separately before, but I am going to write them down again. Guys, the fact that it says and, it means that both of those conditions have to be met. All right? Two events are complementary if they're mutually exclusive and exhaustive. So if they're not mutually exclusive, even if they are exhaustive, they're not complementary. Okay? Both of those conditions have to be met. That is why I've said and. It's not an or. Okay? They both have to be met. So they have to be mutually exclusive and exhaustive. Can anyone remember what mutually exclusive means? Cameron? Yes, they cannot occur at the same time. All right, so mutually exclusive events cannot occur at the same time. And what that means in like mathematical terms, the probability of A and B. Or what can we use instead of and now? What symbol? That R kind of symbol, right? The symbol that looks like an N, you can do that as well. So let's say slash probability of A and B. It's actually A intersection B. That's what that symbol actually is equal to 0. There's no and. The probability of A and B happening at the same time is 0. They cannot happen at the same time. Okay. So what would that mean in terms of a Venn diagram? How would the two circles look? Yes.
They wouldn't have any intersection.
Good. They would be two separate circles. We actually do have that drawn somewhere when we had this one here in our first Venn diagrams note. The first example that we did, these two events were mutually exclusive. All right. There were no numbers that occurred in both A and B in the two circles. Okay, so these two were mutually exclusive. All right, so that is the first one. And then exhaustive events. Can anyone remember what that means if two events are exhaustive? Okay, I'll give you time to think about it while I write this down. Exhaustive events. Yes. No, not necessarily. They do exist at the same time, yes, but there's something extra about those. Let's look at a picture. I think we did also write this down here. If we're looking at that same first example with A and B, we wrote next to that, we said A and B are not exhaustive because all the possible outcomes do not fall in these sets. With you now. So what did that mean? We had a 3 on the outside of these two circles. Yes, what do you want to say?
So I was just going to say that all numbers are included in the...
Yes, so all the possible outcomes of the sample space, right, would have to fall within those two events. Okay, so in this case, what were these again? A and B were numbers smaller than 3 and numbers larger than 3. So the 3 wasn't included in either of those, right? But if we had said, for example, numbers smaller than or equal to 3, right? So that would be 1, 2, 3. And then numbers larger than 3, that would be 4, 5, 6. Right? Then all of the possible outcomes of the sample space would lie within these two circles. So we wouldn't have that 3 there. Then we would say that those two events are exhaustive. All right. So let's try and write that down in words. So exhaustive events. How can I put this in words now? Include all possible outcomes. Is someone saying that? Could I imagine that? Include all possible outcomes of the sample space. Okay, let's put a therefore. Now, guys, the way that we would be able to test for this, or the way that we could write this out like in actual probability notation, is if you have, let's say, A and B, right? Let's say those are the two events. Those are the letters that we used up here. The probability of A plus the probability of B would be equal to 1. Right, if that is the case, then we have exhaustive events. So the probability of A and then the probability of B, basically all of the events, all of the outcomes rather, all of the outcomes are in those events, right? So it's certain. What do we call it again if the probability of something is equal to 1? We call that a certain event. You remember that from last year? If it's 0, we call it an impossible event. If it's 1, we call it a certain event. So if two events are exhaustive, that means that there's nothing outside of those circles. So basically the probability of you selecting either something in A or B is going to be 100%, right? Because there's nothing else. Okay, I'm just going to write an example down here. For example, rolling a die. And then the two events are A is an even number and B is an odd number. All right, so that is the experiment. That's what's actually happening. We're rolling a die. These are the two events. And now the question is asking, are A and B complementary events? Obviously, in a test or exam, they would write all of this out in like a little paragraph, right? I've just done it kind of in shorthand to save some time. So, guys, before we can start figuring out whether A and B are complementary, we need to know which numbers are in A and which numbers are in B. Okay, so I suggest that we list them. And what do we do when we're doing set notation? When we list the numbers in this event, we need to use those curly brackets. Okay, so I'm going to say A, then I'm going to use my curly brackets. Now, which even numbers do I have when I'm rolling a die? Which even numbers are there? 2, 4, and 6. Right, and then let's do the same thing for B. 1, 3, and 5. Now, guys, I get that just by looking at that, you can tell that they're mutually exclusive, right? Because are there any numbers in A and in B? No. So just by looking at those 6 numbers listed there, we can see they are definitely mutually exclusive. And are they exhaustive, guys? Have I covered all 6 possible numbers when you're rolling a die in those 2 events? Yes. But unfortunately, we can't just say it. Okay, we have to do these actual mathematical calculations. Right, sorry, that's off screen. So you actually are going to have to calculate the probability of A and B and write down that it's equal to 0. Therefore, mutually exclusive. Okay, next calculation. The probability of A plus the probability of B equals, get your answer of 1. Therefore, exhaustive. Final line, therefore, complementary. Okay, so it's a bit of a mission. We have to write 5 lines down after this now, but it's like a formal question, right? They're going to ask you to prove whether it's complementary or not. Okay, so let's do that, guys. First thing, A and B. Probability of A and B, or if you wish, you can use the intersection symbol. It's up to you. Are we all in agreement that it's 0? right? Because are there any numbers in A and in B at the same time? No. 0 out of 6, right? So the probability there is 0. Therefore, and now I'm going to write the full sentence out, but you can actually just say mutually exclusive. That's also fine. But basically what we've said now is that A and B are mutually exclusive. Okay, first mark. Maybe 2 marks, depending on who's setting the test. All right, next thing, now we need to test. Are they exhaustive? To test that, we need to calculate the probability of A plus the probability of B. And now, guys, you have to actually show what those separate probabilities are. Okay, how many numbers are there in A? 3 out of how many numbers in total? 6. So you can write 3 over 6 or you can write a half, right? Because do we all agree 3 over 6 is a half? All right, so you can write 3 over 6 or you can write a half straight away. And what about B? How many numbers are there in B? 3 out of 6 numbers in total. So again, you can write 3 over 6 or you can write a half. It's up to you. It's the same thing. And 3 over 6 plus 3 over 6 is 6 over 6, which is 1. Yes, Ross?
Could you say
For this one here. For that one, you can put the N, yes, for the and, yeah. Here, you can't put the union because we have to prove this. It's almost like a formula that you have to prove. Okay. Not now, no. If you're working with the probability identity, you can. Okay. All right, guys, so if it's equal to 1, we're going to say, therefore, A and B are, what did we prove now? Exhaustive. Okay, I've run out of space. I'm going to move my stuff up. Now, final line. Therefore, A and B are complementary. Guys, if one of these two things were not true, you would say, therefore, A and B are not complementary. Okay, so say for the probability of A and B, you got like 0.5. Then they can't be complementary. Okay, so then you would say, therefore, not complementary. Let me just quickly make some space here for myself. Just give me a second. Okay, any questions? Yes.
if you just wrote they are complementary, then would you get all the marks?
Instead of A and B. Yeah, it's fine.